Hello everyone, welcome back. We are in the home stretch for the Chapter 11 homework problems. We are on number 9. And let's see, it says Sonia wants to have $15,000 in 10 years. So right now, she's about to invest some money and she wants it to be worth $15,000 10 years from now by getting all of the compound interest. Wants us to use table 11.2, which what this is talking about is something called present value. Because the idea is that if you take a present value, which is what you want it to be, this is how much you need to invest right now. How much to invest now. So this is basically what principal you need to have, how much you want to invest now. This is the principal that you need to have so that if you increase it by whatever percent by going times some table factor. And this is the table factor from the other table. This is from table 11.1. If you multiply it times a table factor, you will get the amount that you want it to be worth in the future, which in this case is the 15,000. So actually where this table 11.2 comes from is that if we just take this equation and we solve it for the present value, so in other words, we just divide both sides by the table factor, we will have the present value, which I'm going to write this one, times the table factor equals the 15,000. If we just divide both sides by the table factor, then it will cancel on this side. We will find the present value, which is how much she needs to invest now. It's going to be 15,000. And then if you'll bear with me, instead of writing divided by table factor, I'm going to go times 1 divided by the table factor. So if we multiply this, the 15,000 goes times the 1 because this is like 15,000 over 1. It will multiply the top and then the table factor will be on bottom. But this value right here, 1 divided by the table factor, which of course is just the reciprocal of the table factor. For example, if the table factor is 4 over here, we're multiplying times 4. Then over here what we're doing is we're going times 1 over 4. And the whole table 11.2, which we can look at what it looks like here. Table 11.2, see all these numbers are less than 1. In the previous table in 11.1, all the values are more than 1. And it's because every single one of these entries is just 1 divided by the table factor from the other table. I hope that's not too confusing, but we will see that we can do this one just using a formula as well. But why don't we do this one since we have the table handy. They want it to be worth 15,000 in 10 years. How much should she invest now at 6% interest, compounded semi-annually? So we still need to find the same values like the I value, which is the interest per period, which it's 6% interest, and then semi-annually means twice per year. So really the interest per period is 3%. And then the total number of periods, it's semi-annually, so twice per year. For 10 years, so there should be 20 periods total. So we're looking in the table for the 20 row, and which column was it? It's the 3% column. 3% column with the 20 row, which is down here. It's at 0.55368. That's our table factor. So we're going to take this one, and we're going to go 15,000. And then we have the table factor. I'm going to put it here. I know it's getting a little bit jumbled, by the way. I'm sorry about that one. But the table factor, we found it. It's the one that goes yeah, there it is. It's the 0.55368. So if we multiply that times our 15,000, which is what we want it to be worth, times the 0.55368, that means if we invest that much, the 8,000, I know it's getting a little bit messy here and I do apologize, $8,305.20. If we invest that much now, then 10 years from now with this interest rate and so forth, it will be worth $15,000. So that's how we're going to do this one. And then we can do the same thing as far as creating a new table factor by multiplying the two. That will add up to the correct number of periods. But here I just want to use the formula. The formula is so much better. And the formula that we're thinking of is the present value. Well, why don't I write it this way? This is our old formula, 1 plus I to the n. Where this principle, if we're thinking from a sort of a standpoint that in the future, we already know what we want this compound amount to be in the future, and we're solving for the p, then the p is not going to stand for principal anymore. It's going to stand for present value. Those words sort of mean the same thing. But if we just divide both sides of this equation by the 1 plus I to the n, and we have over here 1 plus I to the n power, it will cancel on this side, and we will just get that p, which this time means present value, equals the compound amount, which is how much we want it to be worth later, divided by 1 plus I to the n. And this whole thing we could think of as well as going the amount that we want it to be worth in the future times 1 over, which this is giving us the reciprocal of that thing. These are the same, but this is how we get all the table factors from table 11 too. So it says here, you wish to have 23,000 in 8 years. We need to invest at 6% again, compounded quarterly this time. So the I value, which is the rate per period, it's 6% for the whole year, and quarterly means 4 times per year. So that's 1.5% per period. Then the total number of periods, it's quarterly for 8 years. So 4 times per year for 8 years, 4 times 8 is there's 32 total periods. So what we can do is we can go that compound amount, or the amount that we want it to be worth in the future, which is the 23,000. And then we're doing that one divided by 1 plus 1.5%. We will have to think of that 1.5% as a decimal. We will have to move the decimal place 2 places to the left, and it goes to the 32nd power. So why don't we see what we get? It goes 23,000, and then it's going to go divided by this time, and now we're doing 1 plus, let's see, 1.5%, so it should go 0.015. That's 1.5% as a decimal, because the decimal place, of course, would go once, twice in between the 1 and the 5. And then we're going to the 32nd power. And what do we get? We should invest $14,000, $14,282 to be exact. Oh, it's getting too big. $282. And then we're going to have to round it. It's going to go 84 cents. That's how much we will need to invest. And now, what are we talking about? It says for number 11, Stuart Daniels estimates that he will need $24,000 to set up a small business 8 years from now. Wow, he's really forward thinking. It says, how much must he invest now at 8% interest, compounded quarterly, to achieve his goal? So what do we have? We need to have an interest rate per period and a total number of periods. The interest rate per period is 8% for the whole year, and there are 4 periods. So that gives us 2% per period. And then the total number of periods, it's quarterly, so 4 times per year for 8 years. We're getting the same one. We're getting 32 periods total. And so the amount that he needs to invest now, which is the present value, that's going to be his hopes for the future value, which is 24,000, and then divided by 1 plus the interest rate per period, which I'm going to just convert it to a decimal right away. It's going to go 0.02, and then to the 32nd power. If we do this one, 24,000 divided by 1 plus 0.02, and then to the 32nd power. And you'll have to be careful if you're using a scientific calculator for this one that you are not violating the order of operations to get the wrong answer for this one. Definitely we want a number that's smaller than what we started out with. He doesn't want to invest more and end up with less. Actually, he should start out with less, which is like this 12,700 figure, and end up with more, which is the 24,000. So let's see. He should invest $12,735, and it goes 199, so we can round it up to 20 cents right there. And this is how much compound interest will he earn on the investment. So it's asking what is the difference basically between what it's worth at the end, which is the 24,000, and how much he invested at the beginning. He gained, it almost doubled, not quite. He gained $11,264.80. And then last but not least, so suppose you wish to have $11,000 in 11 years. We're going to use the formula to calculate if you have 6% interest compounded semi-annually, how much do we need to reach our goal? So that present value, it should be the amount we want it to be worth in the future divided by 1 plus the 6%, but we need here the I value. So the I is 6% for the whole year, but then it says compounded semi-annually, which semi-annually means twice per year. So this goes 3%. The total number of periods, let's see, for 11 years, it's twice per year, so there's 22 periods. At the very end, there has been 22 periods total, and the period, or the interest rate per period is 3%, so I'll go plus 0.03. Then let's see what we get, 11,000 divided by, and then it's going to go 1 plus 0.03 to the 22nd power. So you will need to invest, or rather, yeah, it's talking about you. You will need to invest this much, $5,740.80. We will round because it goes 81, but then it's a 7 after the 1, so it should go 82 cents. And that's how much you will have to invest. So that does it for the Chapter 11 homework. Please let me know if you guys have any other questions. And thank you for watching.